All right, today we're going to talk about parallelograms. Today's lesson and day 2, when we talked about angles, they kind of go hand in hand. The difference is I've got a bunch of angles here. I've cut it off into a parallelogram. So there are 4 properties of parallelograms. I hope I can remember them all. The first one is, if it's a parallelogram, I know the opposite sides have to be parallel. The symbol for parallel lines are little triangles. Sometimes you'll see one set of triangles, sometimes you'll see 2. Sometimes you could see more than that. But what this means is these both have one little triangle marking. That means AB and CD are parallel. These 2 have a different set of triangle markings, which means these 2 are parallel, but these 2 are not parallel with each other because they have a different marking. Does that make sense? They're marked differently. Now I know 2 lines are parallel if they have the same slope. Later on in our lesson, we will do this kind of stuff, but we're going to put it on a coordinate plane. Let me see if I can skip ahead really quick. So like these problems right here. So I'm going to put problems on here, points on here, and I want you to decide if it's a parallelogram. Well, one thing I'm going to look for is, are the slopes the same? Okay, the next thing we're looking for, or that we know about parallelograms, is that opposite sides are congruent. Now, if opposite sides are congruent, if this is 6, AD has to be 6. They would have to be the same. Thank you. If AD is 6, do we know anything about AB? We know absolutely nothing. Only thing that we know is that opposite sides are congruent. This could be 8, it could be 4.5, it could be 19. We know nothing about this. Only about the opposite sides. The third thing we know is that opposite angles are congruent. Which means if this is 75 degrees, which other angle do we already know? If angle A or angle C is 75, we know which other angle. Well, opposite of C is A, so this would also have to be 75 degrees. Opposite angles are congruent. The last thing that we're going to talk about today is that consecutive angles and by that I mean like C and D, the ones that are next door to each other. Consecutive angles are supplementary. I ran out of room. No. Consecutive angles are supplementary, which means if angle C is 75, I could quickly find angle D. And how I would do it is I would say 180, because supplementary means adds up to be 180. 180 minus what? And so angle D would be 105. Okay, so I believe on your homework, look really quick. Are there just a couple where it's a very quick? Let me pull up the homework. Try the first 4 on your homework. Just make sure we're on the same page getting them right. Okay, so here's what we need. Okay, so what we know is we know that opposites are to the same. So this is 8, this is here, so it's 6 and 6. So what would this side be? Okay, so these are opposite. So if this is 75, this is 75, this is 74, this one is. Now this one right here, these two add up to be 180. So 180 minus 75 is 105, that's D. Same thing, this one and this one add up to be 180. Good. Yeah. Okay, so we're good here, we're good here, we're good here. So what do we know about these two? What do we do here? So we said 180 minus 75 is 105. Okay, let's check it. What do we know about opposite sides? Oh, that's pretty. Hold on. Okay, what do we know about opposite sides? They're equal, so QT is 8. What do we know about opposite angles? They're the same, so angle V is what? 74 degrees. What do we know about opposite angles again? They're the same, so angle Y, 54. And what do we know about consecutive angles? Here's the one if you're going to make a mistake, this is where it is. What do we know about angle V and angle U? They're supplementary, which means, good, so what, you don't actually have to write this if you can do it in your head, but if you need to, go for it. That means angle V is 140 degrees. Okay, are we good on the first four? Fantastic, moving on. Now, we're going to do the exact same thing, except for we're going to use a little bit more algebra. Let's jump around a little bit. You have to be really careful because there's two different things I could ask for. I could say, solve for x. Like you don't talk all year so far, and then the day I'm recording. Really? Okay. So I could say solve for x, right? Or I could say find the measure of angle E. Be very careful what the question is asking for. In order to find out how big this is, I first do need to solve for x. So I know angle D, I know angle F. What do you know about those two pieces? They're the same. So how would I set up an equation to solve for x? Morgan?
You have like negative 6 plus 14x equals 13x.
Perfect. Because they're the same, right? We can set up an equation. We know the opposite angles are congruent. Set up the equation. So let's subtract the 14x. Divide by a negative 1. So x equals 6. That's the first part, but that's not the answer to my question, right? How am I going to solve angle E? Well, there's nothing to plug into right here. So what do you think? Okay, let's plug it into the 13x first. When you do, have you already done that? What do you get? $78, okay. So angle D is 78, but that's not what the question is asking for still. Sydney? Yeah, we know D and E are supplementary, so subtract it from 180, and we'll get angle E. Now these are things you're going to have memorized for the test that's coming. This is the last day of our unit. Next time we see each other after Labor Day, we will review, and then we test on Thursday the 8th. These properties, knowing what to do here, that's something you need to have memorized. But you'll have lots of practice between now and then. And if you ever don't remember what to do, I mean, look at it. This is kind of an acute angle, right? This is an acute angle. Generally, I say don't trust the picture, but at least the picture can give you a guideline. These look like they're kind of equal, right? So if you have absolutely no clue, sorry, hold on. If you have absolutely no clue what to do and you really don't remember, but you know either I have to set them equal to each other or add them together, by looking at the picture, my guess would be setting them equal because they look equal. Use the picture to guide you. I mean, you can't always trust the picture, but it can give you a point of reference. Yes? We sure would. We sure would. Even just looking at the picture, if you don't remember the fourth rule, that consecutive angles are supplementary, this looks acute. This looks obtuse. Do they look equal? No. So I'm not going to set them equal. I'm going to add them together. When I add them together, what do I get? 35x plus 5. Is that okay? I'm going to add them together, and I'm going to set it equal to 180. Why? Because consecutive angles are supplementary. So let's subtract the 5. Divide by 35. And I don't know what that is. 5, maybe? 3, 5? 5. And it's really easy to stop there and say x equals 5, circle it, feel good, and be done. But then go back. What does the question ask for? Well, it asks for angle M. Which other angle is equal to angle M? K. So if I want to find angle M, I'm going to plug it into angle K. When I do that, I get 100 degrees. Okay, now that we've done 2, yes, the ones we've already done are angles, but I want you to try part C. Using those 4 rules from above, let's see if you can figure out what KL is. And I want you to try something. Don't wait until we do it together. Even if it's wrong, try something. Get with the person sitting next to you. Maybe have them help you if you're not quite sure. You're partners for a reason. Well, you added them together because they're next door to each other, right? So they add up to 180. If I were to add them together, then we could set it equal to 180. Yeah, both of them equal 180. If this one alone did, it would just flatline. Okay, so what do we know about opposite sides? What do we do here? 8, 8, right? Equal. So these two are equal.
No, okay, so they.
What do we know about opposite sides of a
How
parallelogram?
does that look the same? So what you're going to learn what instead of a plus sign is an equal sign. And then.
If you feel good about part C, go ahead and do part D. Opposite sides of a parallelogram are what? Equal. So what are we going to do? Set them equal. Because we don't know anything about sides. We don't know if they're right. This would be probably like right? So rather than like let's switch opposite sides, we don't know what it is. So let's say there was 3x minus 4. And then you'll get like x.
It's catching up.
You can wake up and you're mad. Like, it doesn't really matter, like, you wake up and you're mad.
Yeah.
I feel bad. I'm wrong. I'm so warning. I was looking at
Pull
it.
you out of the dream. Like you're like, and all of a sudden, like, it feels like you're like getting sucked out.
Okay, let's do this. Now again, when we did problem 1 on the homework. I don't know where it is. Okay, we did problem 1 on the homework. We said opposite sides were equal, right? If that's 8, that's 8. So we're going to do it again. But this time, we're working with variables. Now, it's really easy, and I've seen this a lot of times, every single year. What do we know about these two? The only thing we know about them is that they are equal. We don't know what they add up to. They could be adding up to 2. They could be adding up to 150 or 180, but not always 180. So I don't want to ever set sides equal to 180, unless I'm told specifically that they do. All I know here is that opposite sides are equal, are congruent. So let's set those measurements equal to each other. I'll say 3x minus 4 equals 2x plus 1. Which of the 4 rules is this using? Rule number 2. Good. Subtract the 2x. So x minus 4 equals 1. Add the 4. X equals 5. Very good. Now what? The question doesn't say solve for x. Make sure you read the question. I don't remember what the test says. It says find KL. Unless you know anything about this right here, the question can't ask you to solve for KJ. Because even though KL ends up being like 11 or something, we know nothing about KJ. It could be 0.07. We have no idea what KJ is. All we can do is plug it in for x. So 3 times 5 minus 4, 15 minus 4, 11. Yes. Ooh, if it doesn't, then we've done something wrong. Let's try it. So if I plug 5 into here, it better be 11. It does. We're good. Because you said it. If it doesn't, that means probably your algebra is wrong a little bit. Yeah. Because when you plug it back in, those sides should be the same. That's a really good way to check yourself too. You plug it in, you got 11, but what happens if you don't get 11 down here? Then you've messed up somewhere and you probably should start over and try again. Let's do the next one. Let's make sure we got this. These are what? Opposite sides. So which rule are we using again? Number 2. We know that opposite sides are equal. So x plus 6 equals a negative 2 plus 3x. I don't have a lot of room here, so minus x. I get a 2x. I'm going to do this in one step because of space. Add 2. Sorry. You get 8. So if 2x equals 8, what does 1x equal? 4. Now which side do I have to find? Okay. So negative 2 plus 3 times 4. This is why we talked about order of operations that first day. 3 times 4 is 12, plus a negative 2 is 10. Beautiful. Let's keep going. All right. Slope. You've done slope for a while. Slope is just saying how steep something is. Now when we talk about slope, we talk about the change that's happening in the y over the change that's happening in the x. There is a formula for slope, and I'll give it to you this time. The formula for slope, if I'm talking about the change, if I want to find the change of something, I subtract. So the slope formula is, m is the letter we usually use for slope. I need to figure out how far the y values are changing. So y2 minus y1 over how far the x values are changing. Now I do care about negative positive here, so be careful. And it doesn't matter if I'm looking at part A, it doesn't matter which one's x and which one's y, as long as we're consistent. So I'm going to label these x1, y1, because this is what that means. This means this is the x value of the first point and the y value of the first point. This is the x value of the second point, the y value of the second point. If I've seen mistakes right here, usually, I don't see a pencil. Okay, don't write this down. If there's a mistake right here, it's usually because you've gone x1, y, or x1, x2, y1, y2. That is not the way to do it. Again, what it means, x value of the first point, the y value of the first point, the x value of the second, the y value of the second. Now let's plug that in. Formula says y2 minus y1. So y2 is a negative 6 minus y1 is a negative 3. The x2 value is a negative 8 minus 4. And then we simplify. If you struggle with simplifying your integers, you may want to make sure you have a calculator. That minus will become a positive. Negative 6 plus 3. Here's how I think of that. I have $3 and I want to spend 6. First of all, do I have enough? No. How much do I need in order to have enough? I need 3 more. So I always like to think of it as spending money because we're used to that. This one right here, I spend $8 and I spend 4 more. I have spent how much? 12. Or use a calculator or whatever. Okay, simplify that. The negatives cancel. 3 over 12, what will that reduce to? 1/4. Let's do it again. y2, or x1, y1, x2, y2, y2 minus y1, x2 minus x1. 2 minus 6 is a negative 4. Negative 5 plus 7 is 2. And then negative 4 divided by 2 is negative 2. All right, we've already talked about the first one. How do you know if two lines are parallel? They have the same slope. How do I know if two lines are parallel? Because they have the same slope. Two lines are perpendicular if their slopes are opposite, which means negative, opposite reciprocals. So, reciprocal means the flip. So if I'm looking at part A, is 2/3 and 3/2, are they parallel, perpendicular, or neither? Well, they're not exactly the same, so they're not parallel. For perpendicular, they have to be flipped, which they are, but are they opposite? No, one of them would have to be negative, right? These would be perpendicular, which means if they're not parallel and they're not perpendicular, they would have to be neither. You've done this before, right? This should be a review. This one right here, they're both 3/4, which means they have to be what? Parallel. All right, for part C, we got to figure this one out. A line containing the point 4,3 and 2,6, and a line containing the points 9,8 and 6,6. So here's my first line. If I want to know if this line is parallel, perpendicular, or neither to the other line, what do I have to do? We have to check their slopes. So let's find the slope. In fact, let's split it up. If you are on this half of the room, there's not as many of you, will you find the slope of the first 2 points? And then if you are from Sydney over, we find the slope of the second 2 points. Let's just make sure we're all on the same page. We can all do it. Then I'll have you compare yours with mine.
Do you have any whiteout?
I don't have whiteout. So, just like last time, if you, this is recording, I have to go to the store, dang it, I forgot. Just like last time, if you have some that are reused, just put them in my front pocket and I'll take care of them. And then I'll wipe them out and cross it out or just
Plus
something.
and 7, right? Both of them.
Oh,
Is that not
okay.
negative?
Let me see. Okay, 6. All right, so for the first one, I got 3 over negative 2. Did you guys agree? 3 over negative 2. This one, 6 minus 8 is a negative 2. 6 minus 9 is a negative 3. All right, are those parallel, perpendicular, or neither? This one is 3/2, the negative. This one is negative or positive? Positive, those will cancel. So yes, they're flipped. One's negative, one's not. Are they parallel? Did I screw up?
Wait, but how did you get the negatives? Like, why am I seeing 6 minus 3 instead of adding them?
Right here?
Yeah.
Because the formula is minus up here. So y2
Oh.
minus y1. So yeah, right here. 6 minus 3 is 3. 2 minus 4 is a negative 2. Right here. So they're not parallel. Are they perpendicular? Yes. Because they are flipped. One's negative, one's positive. I'm going to call them perpendicular. Okay, so the last thing we have to do, called a coordinate proof. This word's kind of scary. It's not that bad, I promise. You just have to say why something's true in it, like a paragraph or a sentence or two. So it kind of gives you some steps on how to do this. Here's how we develop a coordinate proof. 1, we're going to draw and label the graph. 2, we're going to say any formulas we're using and show all of our work, including any computations, and then have a concluding sentence. So, mine's frozen. There we go.
Quadrilateral ABCD has the following points. The first thing we're going to do is we're going to put them on the graph and we're going to make sure the A, the B, the C, the D are on the graph. So A is 2, 5. B is negative 2, 7. Negative 1, 3. And 3, 1. Now on the homework today, you have 3 of these. The first question tells you how to prove it. Because if we go back to our rules, on the previous page, 2 previous pages, these are the ways I can prove that something's parallel, or a parallelogram. 1, I can prove it because the sides are parallel, which means the slopes are equal. It's probably the easiest way. I also can prove it because opposite sides are congruent. So these are the 2 that we'll be using for our proofs. It's really hard to prove that angles are congruent. You'd have to do that using something you don't know how to do yet. And then consecutive angles are supplementary. Again, very hard to prove. You don't know how to do that yet. So these are the 2 we're going to look for. So for number 1, we're going to use the slope formula. For number 2, we're going to use the distance, which is, from yesterday, a squared plus b squared equals c squared. So again, on your homework, you have 3 of these problems. The first one says, prove it by slope. The second one says prove it by distance, and then the third says just prove it. Okay, so if I'm using slope for this one, or if I'm using the idea of parallel lines, if I'm using the idea of parallel lines, I would have to show that AB is parallel with CD. I would have to show that BC is parallel with AD. Now I'm going to prove that they're parallel by using slope. So if I'm starting here and going down to C, I'm going to kind of make it into a triangle. What slope is that? I don't have to use a formula. I can just count because it's on a grid. I went down 4 over 1, right? Hold on. So off to the side, I'm just going to put the slope of BC is -4. Now, if it's a parallelogram, the slope of BC will be the same as the slope of AD. So if I'm trying to find the slope here, again, I go down and over. How far did I go down? From A, 1, 2, 3, 4, over 1. So the slope of AD is also -4. We showed right here that these slopes are equal, which means those lines have to be what? Parallel. Let's do it again. I want to find the slope of these two, because it is possible to have one of them parallel and then the other one not. That would be called a trapezoid. So let's look at these two. If I'm starting, I always start on the far left, and you go down and then over. So between B and A, how far did we go down? We went down 2 and over how many? 4. So the slope of BA is -2/4, which is the same as -1/2. And then we'll do it one more time. From C to D, what did we do? We went down 2 over 4. Very good. What do we know about these slopes? They're also parallel. Now our picture kind of looks all junky now, right? Because we've got a bunch of writing on it. But this will help us with our proof. Do we have enough information now to say yes, it's a parallelogram, or no, it is not? So I'm going to say, and here's, when you write a proof, it does kind of, the word sounds scary. It is a little bit more formal, so you need to be a little bit more specific in your writing. Here's how I would say it. I would say yes. Quadrilateral. I'll back up a little bit so you can see it easier. And then we'll name it ABCD is a parallelogram all of this work up here backs or supports your answer. How do we know it's a parallelogram? Because opposite sides are parallel. There's one of these on the test. So you'll have between these two and then the 3 on your homework and however many on the review. Hopefully you'll have plenty of practice before we actually get to test time. It's a little bit of a longer problem, right? Woo! Slope is my favorite way to do it. It's a lot easier than distance, but on the test you can choose how you want to do it. On the homework you have one that you need to use slope, one that you need to use distance, and then one that you get to choose. Any questions on that one, or do you want to just see it again? Yeah, Joseph.
How do you use distance?
Good question. Let's see it again. Let's do distance. So this next one will focus on using the distance formula. In our case, we use Pythagorean theorem. So quadrilateral ABCD has the following points. Let's put them on the graph. 3, 0 is Q. Oh, look at that. So ABCD, actually, here's a typo. It's supposed to be QRST. That really matters a ton, but Q is 3, 0, R is 1, 1, S is 4, 5, and T, ooh, typo, hold on, crap. Change that to a 6, 3, not a 2, 3, sorry. So that's a 6, 3 instead of a 2, 3. If I'm looking at it, first of all, does it look like a parallelogram? The slopes look off a little bit. I like when it's not a parallelogram because as soon as you find that something doesn't work, you're done. That's all you have to do. If it is a parallelogram, you have to check all 4 things. But with this one, if I can prove that ST is different than QR, then that's all I have to do. Does ST look different than QR? Probably. Let's check the distance. We're going to use distance. Okay, here's how I'll do it. First, let's find the length of ST. Just like we did last time when we were doing distance formula. Change that into a right triangle. Ignore everything else. How far is this? 2. And then how far is that? 3. So if I want to find the length, I'll say 2 squared plus 3 squared equals x squared. We're looking for the length of that segment. Interestingly enough, we kind of did the exact same thing to find slope, right? The 2 and the 3. That's why slope's a lot faster. So 2 squared is 4 plus 9. Did I screw up because there's like 4 hands, right? Okay, yes. Sydney.
T, it needs to be moved up one or the point.
Ah, thank you. So I put the T in the wrong spot. So this isn't 3, it's a 2. And that's all what y'all were going to say? Okay, fantastic. At least we know that you're all on the right page. Okay, so let's change this a little bit. I stopped talking. This is supposed to be a 2, which means this would be a 4, which means this would be an 8. Sorry, which means this is an 8. And for the purpose of right now, I'm not going to simplify it. I'm just going to leave it like that. Now the opposite side from ST is RQ. So that's this little piece right here, and there's a lot of writing right here. So just do the best you can. We're going to make that into a triangle to help us find the distance. Already I can see that this is going to be a 1 and this is going to be a 2, which I know that it's going to be different, right? If I had a 2 and a 2 here, a 1 and a 2 here, they're going to be different. But mathematically I need to show that. Are you okay with my 1, 2? Let's find the length of RQ. I've got 1 squared plus 2 squared equals x squared. I'm going to look up. Have I screwed up yet? No? We're still good? Okay, keep going. 1 plus 4 equals x squared. 5 equals x squared. So now I'll look at those two numbers. This is a lot harder than the rest, right? Yeah. Okay. I'll look at those two numbers. I've got the square root of 8 and I've got the square root of 5. So we could say that opposite sides are equal or are not equal. They are not. So I'm going to say this is enough work that I have to do, and the math is done. I don't care about the other two sides because I've already found that the opposite sides aren't equal. So I already know the quadrilateral QRST is not a parallelogram. And then I just have to state how I know this. How do I know it? What did we check for? Close. We didn't use, okay, Morgan? Close. We have to check, what did we use? We used distance, right? They're not a parallelogram because opposite sides aren't congruent. And I know they're not congruent because they don't have the same distance. They're not equal. And that would be my proof on that one. So on the first one, I proved it. On the second one, I disproved it, right? Oi, that's all. Thanks for watching. Peace out. Okay, cool. We're done.